Okay, Rachel, here's day 5, which is what we're doing today, Tuesday, more exponent practice. All right, so here are all of the exponent laws that we need to know. When we multiply, we add the exponents. When we divide, we subtract. Raise a power to a power, we multiply the exponents. When we have a fractional exponent, the denominator is the index. And over here, when we have a negative exponent, it makes it 1 over, or if it's under the bottom, it goes on the top. And remember here, we have to share the exponents when we have parentheses, and then anything to the 0 power is 1. So here are all the laws in a nutshell. So now we're just going to practice simplifying today. Nothing new, just making it weird. So there are lots of ways to do this. I probably would do the top first and get x to the 7th. And then the bottom, raise a power to a power, we multiply. So x to the 10th. Notice no negative exponents, so this is going to be 1 over x to the 3, because 10 minus 7 is 3, and there are more to the bottom, so I leave the 3 on the bottom. That make any sense? I hope so. All right, I'm sharing my exponent. I'm thinking x squared to the 4th, and then y to the 4th, over x to the 7th, y to the 5th. You don't necessarily have to write that. I would encourage you to write x to the 8th, y to the 4th, over x to the 7th, y to the 5th. So now I have my x's. 8 minus 7 is 1, and it's more on top. So I put it on the top, and then I have y to the 4 over y to the 5th. 4 minus 5 is 1, and there are more on the bottom, so this would end up being just plain x over y. All right, so this one, I don't know, there's a couple of things you could do. I probably would swap these two places, because x to the negative 2 is going to be x to the positive 2 on the bottom, and x to the negative 6 on the bottom is going to be x to the positive 6 on the top. That's probably what I would do. You could just subtract the exponents, but sometimes with negatives it gets a little tricky. So now I subtract 6 minus 2 is 4, x to the 4. 4 minus 2 is 2, y to the 2, and there's nothing left on the bottom, so just x to the 4th over y squared, or times y squared, sorry. Okay, here I would certainly share my exponent first. So I get x to the negative 6, y to the negative 8, over x to the negative 4, y to the negative 12. And then I probably would switch everybody's place. Put the x to the 6 on the bottom, the x to the 4th on the top, the y to the negative 12, the y to the 12th on the top, and the y to the 8th on the bottom. And then I would do my subtracting, so I get x squared on the bottom and y to the 4th on the top. Okay? But there are lots of ways you can do those things, but no matter how you do it, you should get the same answer. We should all get the same answers. Okay, these are all x's. So I would do the numerator first. So x to the 1/3 plus 1/2. 1/3 plus 1/2 is 5/6. So x to the 5/6 divided by x to the 1/6. 5 minus 1 is 4. So x to the 4/6, which makes x to the 2/3. You can go ahead and just say 5/6 minus, there's lots of ways you can do it, but that's what I would do. So same way here, fixed my numerator. 1/2 times 5 is x to the 5 over 2. And then I have 3/2 plus 3, according to my calculator, is 9/2. So then 5/2 minus 9/2 is going to be negative 2. So that's 1 over x to the positive 2. I used my calculator to do the subtracting, because I didn't want to work that hard. All right, so here I got to share. Make sure you share the 4, the cube with the 4, and then 2/3 times 3 is just 2, and then I have 32 x to the 8th. So 4 to the 3rd is 64. So this is 64x squared over 32x to the 8. 64 divided by 32 is 2. And then I have x's, and I have 6 x's left on the bottom. Okay? All right, rewrite in simplest form using a radical expressions. Oh, simplest form, x to the 5/3. That's going to be the cube root of x to the 5th. If it's simplest form, I should probably rename this as x to the 3rd times x squared and call it x times the cube root of x squared if I'm doing simplest form. Here I'm going to take my calculator and subtract those two exponents and make it back into a fraction. So this is x to the 7/6. So I have the 6th root of x to the 7th. So that's going to be x to the 6th times x. So it's going to be x times the 6th root of x. Okay, I have a negative there, so I'm going to flip it around and make it x to the positive 3/2, which means I'm going to take the square root of x to the 3rd, and I'm going to call that x squared times x. So x square roots of x. Okay, I'm going to jump down here to the Regents question. All right, I'm going to stop actually.